when we start looking at multi-step linear inequalities, really all we need to focus on is the idea that they're really similar to linear equations. If you remember how we solve those, all those properties, the addition, subtraction, multiplication, all those ideas, we can use those the same for these linear inequalities. There's only two differences, and that's for our solutions, it's not going to be one particular x value. It's going to be a range of x values. And two, and the most important one when you're actually multiplying, or when you're actually solving, is if you multiply or divide by a negative number, you have to reverse the inequality sign. So if we started with this one, let's say I just decided to multiply both sides by a negative or divide, then I would have to flip this greater than to a less than. That's what they mean by reverse, okay? So with that in mind, that's the main idea behind these. You have to remember that. And if you can, then pretty much everything else just holds true for the properties. When we, subtract from both sides, when we add to both sides, those same properties hold. So if we look at this first one, we would solve it just like a linear equation. We would want to get rid of everything that's not on the variable. So we can get rid of this 3, and we would get 3x, and we have to subtract 3. We get 3x is greater than 9. And then what do we do from there? We would divide both sides by 3, and we get x is greater than 3. And we can check that because what value is greater than 3? Just pick any random value. We'd think maybe 4, right? So we could try it 3 times 4 plus 3, and we would get a 15 is greater than 12, and that's true. So this actually is true. So this, not that it's true, but this is correct, excuse me. So what we did here is correct. So our solution would be x is greater than 3. And if you remember, when it's just a greater than or less than, and there's no equal on it, then it's an open circle, and we would go to the right 3. And there's our solution. So anything that's greater than 3, it's going to solve this original inequality and be a solution for it. And this is our solution set right here. So with that, let's do the same thing for this next one. We want to solve for that x, so let's get rid of anything that's not attached to the x directly to try and isolate it, and we'll get a negative 10x, and we're going to add 5, right? So add 5 to both sides and cancel this negative 5 out, and we get on the right side, we'll get a 20. And now what do? We're going to divide both sides by negative 10, and we get x. And remember, if we multiply or divide by a negative, which we just did, we have to flip it around. So instead of greater than or equal to, we get less than or equal to, and we get negative 2. And that looks like a funky one. Sorry about that. And this is pretty much it for that. The x is less than or equal to negative 2. So we would get, since it includes that or equal to part, then we'll have a closed circle. And negative 2. Since x is less than or equal to negative 2, it's going to be to the left. And we can check any value that we want. What's a value that's less than negative 2? We could pick maybe negative 3. I like that. Sounds good. So let's go back and plug it into the original. We get negative 3 times negative 10, which is a positive 30, minus 5 is greater than 15. Let's figure out if this is true. And yeah, 25 is greater than or equal to 15. So this checks out as well. And this is our solution set. So let's make them a little bit trickier. But the same ideas hold true for these ones. We just want to get rid of everything that's not the x. We're basically trying to isolate x. I threw a couple of extra things at you. You can see why they call it multi-step now, right? So let's get rid of this 3. So we're going to distribute that 3. And what do we get? We get 3x plus 9 minus 5 is less than 13. So we get 3x. We can combine the 9 minus 5 to become a positive 4. Minus 13, and then we subtract the 4 off, we get all this stuff. So if you're not comfortable with how I'm doing this, then you must go back. You have to go back and double check how we solve linear equations, because these are the exact same properties. Anything I do to one side, I do to the other. So with this, we're really close. We don't care about what 3x is. We want 1x, so we're going to divide off that 3, and we get x is less than 3. So open circle to the left. And we can double check. Let's pick any value that's less than 3. I think a very nice and easy one is 0, right? So let's plug that in up here. We get 3 times 0 plus 3 minus 5 is less than 13. Let's see if that's true. 3 times 3, right? 9 minus 5, less than 13. 4 is definitely less than 13. And there we go. So with this last one, I wanted to throw an extra step in there, one more extra step. And we have variables on both sides, which is not a problem at all. We just want to get them on one side. So we're going to go about our business exactly the same way. So we're going to distribute that 2. And now what? We can either bring this 2x to the right or we can bring this negative x to the left. I'd prefer to bring this negative x to the left because it'd become positive. We don't have to deal with a negative value of a negative variable, which is still fine. We can definitely do that. But if we bring this x over, actually, you know what? Let's bring the 2x over so we can have a negative in there. So if I subtract 2x from both sides, I get negative 4 plus 3 is less than, and what's negative x minus 2x? That gives us a negative 3x, and there's still a plus 1. And now we have the variable on one side. Now we want to get anything else that's not the variable to the left side. So let's bring this plus 1 to the left by subtracting, and negative 4 plus 3 is just negative 1. So if we subtract 1, we get negative 2. Okay, and now we don't want this negative 3 attached to it being multiplied by, so we divide that off. And since we just divided by a negative, we have to flip the sign around. Positive 2/3. So x is less than 2/3. Or you could you could read it as 2/3 is greater than x, right? Same exact thing. So x is less than 2/3. We can pick any value of that's less than 2/3. And again, we can pick a nice easy 0. That's a good one to plug in. And let's plug it into the original. And I put a 0 here because negative 1 times 0 is just a 0 still. So we get 2 times negative 2. So negative 4 plus 3 is less than 1. And what do we get? Is negative 1 less than 1? Yes, it is. And there we go. And then our solution set. And I kind of picked a fraction here just so we could see what it looks like. It would be right about in here. So I'll try and draw a little bit up there. And we have an open circle. And since x is less than that, we get less than and it to the left. And that's our solution set. So with these linear inequalities, they have all the same properties of how we solve them as linear equations, right? The only extra step is that if we multiply or divide by a negative, we have to reverse the inequality sign. And the extra one, it's not even a step, but it's a property, is that with inequalities, we don't get one x value like linear equations. We get a range of x values because this is a inequality. Basically, it's telling us there's a range of x values that will solve this. Okay, and that's what you get. It goes on forever and ever and ever. Okay, all these ones. So that's the main idea behind how we solve multi-step linear inequalities. But if you have any questions or comments, please leave them below. And until next time, this is Justin with Top Tier Math.